All right, so we're given three statements, three compound statements, and we want to figure out which two are equivalent, if any. So to do this, I need to translate them all into symbolic form. So I have to dissect them into simple statements and identify what P and Q and maybe R will be. So looking at statement A, it's summer and Sam is relieved or Sally is relieved. I guess I'll let P, I'm going to let P represent it's summer. And we'll let Q represent the statement that Sam is relieved. And finally, R is going to be Sally is relieved. All right, so statement A says it's summer, so that would be P, and Sam is relieved, that would be Q, or Sally is relieved, and we have R. And based on the position of the comma in the compound statement, I can insert parentheses before the Q and after the R. And then moving on to statement B, we see it's summer, so that once again we have P and, all right, and this, now we have it is false that Sam and Sally are not relieved. So it is not the case that Sam and Sally are not relieved, or it's false that Sam and Sally are not relieved. So it's going to look like this. It's false that Sam and Sally are not relieved, so I'm going to negate both of those. So not P, actually that'd be not Q, of course. You know, Sam is not relieved would be not Q, and Sally is not relieved, that would be not R. All right, so this statement on B, it has a bunch of negations on there, and in a moment we're going to see we can actually clean that up using some properties. So it is false. That prompts me to put that negation right there, and then parentheses. Sam and Sally are not relieved, neither one of them, so not Q and not R. Statement C, we see we have an if and then, so if it's summer, so if P, then Sam is relieved, that would be Q, or Sally is relieved, R. And based on the position of the comma in statement C, I can put parentheses surrounding the Q and the R. All right, well, truth tables are probably the longest thing to use, and so if we can avoid a truth table to figure this out, that would be nice. Looking at statement B, I can clean all those negations up using one of De Morgan's laws. First, I'm going to remind myself what De Morgan's law says. De Morgan's law says that if we have something like not P and Q, then that would be equivalent to not P or not Q. So we basically distribute the negation, and we flip the connective. Right? So looking at this one, we would have P, and if I distribute that negation, it would be not Q. That would actually become Q. And then I would flip the connective. I'm going to flip that and right there to an or. And if I distribute that negative to the R, it's sort of like a double negative. It's not R, so that becomes R. And check this out. If we look at this, after using De Morgan's law, applying it to get rid of all those darn negatives, that is exactly the same as A. So they're exact the same. This is great. They're obviously equivalent. It's the exact same statement. So with the help of De Morgan's law, after cleaning up statement B, I now see that statements A and B are equivalent, and I don't need a truth table. And so the answer is, of course, answer choice B. Statements A and B are equivalent. Now, since this is multiple choice, there is no option, about maybe is all three the same, if if we were left to wondering, all three of these statements, which ones are equivalent, in a way I wouldn't really be finished. I now know that A and B are the same, but hey, maybe statement C is the same as A and B as well. But based on the way that the answer choices are arranged, that's not an option. There is no option for A, B, and C, and so the problem is essentially done due to the dynamic of the multiple choice of the choices that I have. But maybe just to do it, what if we wanted to know if statements A and C were the same? Well, there is no De Morgan's law for that, so in order to investigate whether A and C are the same, I could set up a truth table. Now, again, based on what I see, it looks like they won't be, because the answer wasn't A, it wasn't A and C, so I already know it's not A and C, but just for practice, I'm going to go ahead and make a truth table. And what I'm doing is I'm going to confirm that A and C, those statements are not equivalent. So here we go. I have my P column, and then we're going to have a Q column. Now, the thing with this one is there are three simple statements, P, Q, and R. Making a truth table for three simple statements is a lot of work because there's 8, that's right, there's 8 different possibilities. P could be true, Q could be true, R could be true, P could be true, Q could be true, R could be false, and so on. There's 8. There's going to be 8 rows. Now, if we needed to make a complete truth table, I'd have to make them all, but maybe we won't need to. I only need one row to be different, and I can know they're not equivalent, so we might not need to do all 8 rows. If they wanted a full truth table, I would. But let's see. The statement A is P and Q or R. So in order to create that, I will need a Q or R, and then after that, I can do the P and Q or R. So Q or R. Looks like I would have true and true, because it's an or as long as one of them are true, it's true. Now I have P and Q or R. Well, in the first row, P is true and Q or R is true. So yes, they are both, P is true and Q or R is true. Same thing with this one. Right, so true and true is what I see for statement A so far. The other statement is that I'm investigating, statement C, is if P then Q or R. The nice thing is I already have a Q or R column created, and here we have a conditional. If P is true and then the second part's false, that's when this would be false. But all right, so on the first row, P is true and Q or R is true. Same thing with the second row. So far, this and this are the same, right? That's unfortunate. That means I have to keep going, into the third one. So another option would be true, false, true. Another one after that would be true, false, false. So Q or R would be true here and false here. P and Q or R. It looks like P is true on the third row and Q or R is true on the third row. So yeah. But on the fourth row, P is true and Q or R is false. So this would be false. On the third, now we're looking at the last column. If P is true and Q or R is true, so this would be true. And on the last one, P is true and Q or R is false. Here we have P is true and this one is false. So that means the conditional would be false. And shoot, they're still matching. Again, A and C are not supposed to be equivalent based on our answer, and I'm trying to prove that with the truth table. But the first four rows, they are matching. So I need to go deeper. I need to go to more rows, and I'm running out of room. Another option would be false, true, and true. So let's investigate that. Q or R. Yep, that would be true. P and Q or R. that would be false because P is false. Q or R is true, but P is false. And over here, it looks like we're going to get to quit right here because check, we're looking at this last row, the fifth row underneath this line. It looks like P is false. So it doesn't matter what Q or R is. This would be true. And it took us to the fifth row. You know, fortunately we didn't have to go all the way 8, but I now see that this statement and this statement, answer choices C and A and C, are different on row 5. And who knows if they're going to be the same on rows 6, 7, and 8. Again, it doesn't matter. It only takes one set of conditions for them to not match to confirm it's not equivalent.